Hello, everyone. How's everybody doing? Hope you're doing fine. I'm doing okay, I guess. Like I said once, I'm 66 going on 90. Probably going to be dead in 5, 6 years, who knows. Anyways, today's confession day. Okay, I got a lot to confess. People have been prodding me and saying, Bill, you're not for real. And so today is confession day. I have to confess, yeah, I really work for the CIA. I'm in a disinformation mode. That's my job, to disinform the public. And specifically, I work in the Flat Earth Disinformation Division of the CIA. And that's my job, to disinform specifically people in the Flat Earth Society. Okay? So I had to confess this because I think there's going to be a press conference, or Donald Trump's going to announce it to the world. Humans never went to to space, to the moon, okay, and things of that nature. He's going to be talking about that in a couple of days, so keep your eyes out for that news. And here you get just a little introduction to what Trump is going to be saying to the world. Okay, so yeah, we've been fooling you all these years. Man did not go to the moon. Man has never gone to space. The Earth is not a globe. It's not round. It's not a sphere or spherical. It's like the flat earthers have been saying all these years. It's flat as a pancake. And so, yeah, I mean, it's kind of sad because I'm going to be losing my job soon. I mean, if they tell you that the Earth is flat and it's official, well, what's the purpose of flat Earth disinformation? I mean, we run out of a job. They don't need me anymore. So for me, it's sad because after so many years of working in the flat Earth disinformation group, it's kind of sad to see that whole operation go down the drain. And yeah, not only me, but remember Professor Dave I talked about the other day? Well, he also works there. He works in the flat Earth disinformation group. Our job is to disinform specifically the flat earthers. These are very smart people, so it takes a long time to try to really find ways of convincing them, persuading them, changing their minds. And it's not easy to do. They stick to their story. They say, no, no, it's irrational for the world to be round, and to say that you sent probes into space and that there's vacuum in space. Yeah. In fact, some people believe that I live in Germany, that I'm talking from Germany. Can you believe that? No, no. This here is Langley, Virginia. This is my office here, and uh, Professor Dave, he works across the hall here for me. Okay, so yeah, we work together. We've known each other for years. And yeah, so the other day when Professor Dave came out there and said, things like, trying to ridicule these people and showing that the Earth is really flat, round and not flat. He was just trying to disinform you. And he went through all this, you know, uh, thing about the seasons and the day and night and eclipses. How do you explain all that? Sure, you can't explain it with a round Earth. You can only explain it with a flat Earth. Okay, so yeah, uh, again, very sorry, sad to see all this go down the drain finally. And yeah, you can see why the Earth cannot be round and why the flat earthers have been right all these years. Look here's proof, evidence. Okay, so please keep an eye on it. So yeah, I mean, if the Earth were round, men would fall off the Earth. Okay, so obviously, I mean, how can you think that the Earth is round? And and imagine the Earth spinning. Imagine if you're in Australia, all the kangaroos would be flying right out of the Earth. They'd be flying out into space. I mean, obviously the Earth cannot be round and moving, spinning, because you would have all these ridiculous situations where, men and kangaroos fall off the Earth. All the Australians would be, falling out. And, this is the correct model here, as you can see. Uh, yeah, the sun and the moon, they just go around the Earth, around the perimeter of flat Earth, as these people have always been saying. And as you can see, the sun is about the same size as the moon. The only thing they got wrong here, that I will correct them a little bit, okay, because we have taken some measurements, is that the moon is slightly bigger than the sun. Okay, just keep that in mind. That's something that you've got wrong, flat earthers out there. It's the other way around. The sun is slightly smaller than the moon. Okay, and yeah, here you can see why people don't fall off the earth. The earth is flat, and everybody's just standing straight up. I mean, compare that to what I just showed you. I mean, if this is the case, men would fall off the southern part of the earth. Obviously, that cannot be possible. Okay, no, the earth is flat, and you can see it here. All people standing upright, okay, vertically on a horizontal earth. That's the only way you can conceive the earth. I mean, just prove it to yourself. Walk a mile, walk 2 miles, walk 5 miles, and you'll see it's always flat. Okay, it's always flat. Never do you see curvature. Okay, so I mean, and yeah, and they accuse us, the flat earthers. They accuse us and they say, look, because we say, well, why don't you go to the Antarctica and find out if you fall off or what happens over there? You can see. And they say, well, you guys don't allow us to. And they're right. We got all our military, guarding the strategic area, the Antarctica. I mean, it's all around. As you can see there, big stretch of ice, really, not land. You can't say land because it's so cold down there. And so we send all our military guys there, and to prevent you from seeing really that edge. And that's that allows us to keep you away from the edge of the earth. Okay, so yeah, you'll see it here. These people, you can see that they're standing upright, okay? But what we do to make sure that you don't get to the edge of the earth, we put soldiers all around it. So to make sure that nobody even dares get close to the Antarctica, okay? We don't let anybody in there because you might discover, what's happening. But I want you to know that this is not only a military issue, okay? Please think that there's something else going on here. And what's going on, there's also a scientific issue involved. Because, see, we found a leak in the ice. The ice is there also to protect the oceans, otherwise the oceans would be flowing out into space, okay? And so what we found is there was a leak in one of the pieces of the Antarctic ice, and the water of the ocean was coming out there. We had to plug that out real quick because we were worried that it would drain the oceans out into space. So yeah, we had to correct that as well. And so it's not only a military mission, it's also a scientific mission to make sure that there are no holes in the ice. Okay, keep that in mind. It's not only military. Okay, it's not only to disinform the public and not allow you to really verify, what's out there. No, it has to do also with, not allowing the waters to flow out into space. Okay, uh, there is a correction I need to make a little bit, just now that we're out in the open. I mean, we've blown our cover here. Okay, so I mean, so there's no need to hide anything else from you. The only thing I want to make a little correction. This is your flat Earth map, and it was pretty much accurate. Okay, it was close, very close. But I want you to know that we also tricked you on the forms and the shapes of the continents. See, we do that. We do that reading also. We send our geologists out there. We send our surveyors out there, and they really work to mislead you a little bit, okay, for different reasons. So no, no. What you got wrong is the shapes, okay? So let me show you really what our map looks like. It looks a little bit like this, okay? All the English speaking countries are on the east side of the earth. And here I'm just going to circle them so that you can see them. See, you got England in the little circle, and it's close to North America because they're all English speaking countries. Okay, so you've got Australia, which is not as big as it really is, it's just a little island there. And there's a piece of Southern Africa that doesn't really belong to Africa. We call it really South America, not South Africa. You know, here at the CIA, you know, we have these terms. And yeah, that piece, that chunk of Africa really is not part of Africa. It's south of the United States, okay? And you have all the English speaking countries on the right hand side, on the east side, and all the shithole countries, you know, on the other side. Okay, that's the way it works. And you know, and you can see why, and I'm sure a lot of you figured it out, that the reason you can't fly directly from Africa to South America, you got to go to Europe. You know, you got to take a plane from Africa to Europe before you go to South America. And now you know why. Yeah, of course. It's that Europe's in the way of Africa and South America. And the southern tip of South America is, of course, not pointing towards the Antarctica. It's close to, you know, the North Pole. That's why it's so cold over there. Okay, so this is the real map. But you were onto something. I mean, you know, you really had a good idea of we weren't able to fool you. Okay, and so yeah, we tried. I want to show you a couple things. You know, here I'm going to set it up here because you were able to figure some of these things out. Okay, let's see if I can set it up here. Give me a second here. And what this is how we fooled you. Okay, we really invest a lot of money in these things, so I want you to know. Okay, and you know, you probably heard the feather and the hammer experiment that we did in space. Okay, and as you can see, you know, we did this at the Universal Studios. Okay, we try to make it believable for you, okay, for the public. And then we hired an actor there to do the trick in space. You can see everything is floating. Why? Because it's all hanged by threads. But sometimes the tricks fail. And so he had to cover his tracks, and he said, well, it's, you know, pockets of gravity. Okay? So, yeah, you know, you really have to work hard on these things. And when you screw up, you got to figure out how you're going to cover for the screw up. Okay? And again, you know, what the actor did, he just, you know, let go of the, we had everything tied with strings. That's the issue. And we forgot to tie the card. That's what happened here. Okay. So, yeah, a lot of you figure that out, that there are serious problems with sometimes when we glitch, we make glitches and we screw up. But we fix those anyway with blah, blah, blah. You know, we just say, no, pockets of gravity. And people just buy it because they're, you know, they're not as smart. Here's another one, and this shows you how we do the tricks. Okay, I'm going to show you this. You really need to see this because now you're going to get an idea of how these things are really done. Okay, and here we hired two actors. Okay, and what they do is they do the magic tricks for us. You can see everything is floating upwards. You say, how is this possible? You know, how do we do this? And now I'm going to show you the trick, how it's really done. Okay, how we do it behind the scenes. And this is at the CIA, Langley, Virginia. That's where we do this, okay? We hang these guys upside down, okay? That's how we do it, okay? So that's why everything falls upwards, okay? And some people, you know, really believe that, you know, that gravity is working here, that there's somehow, you know, some trick or something. Yeah, it is a trick, of course. It's a trick, but nobody can figure out the trick. We had to show you this to see how it's done, okay? This is how we do all these tricks, okay? And yeah, we do so many tricks. that people don't even know what to think anymore. They're really completely. That's the point. The more tricks you do, the more tricks you throw in there, the more people are fooled. So they don't know what to believe, and that's the point. You got to keep them on their toes. That's the idea. And yeah, here's a couple more. Here's one. Let me see if I can set it up. Okay. Okay. Here it is. Give me a second here. And let's start at the beginning so that you can see how it's done, okay? How these tricks are done. Because some people really believe this stuff, they don't really know how it's done. And I'm going to show you now how it's done, okay? See, we got this thing, we put it in there, and look at the magic now. And people really believe that this happens, okay? And we have it floating in the air. And of course, we have it tied by a little string that you can't see. It's a little fiber that we specifically made at the CIA. And we bring a glass down to really fool you and say, well, okay, it can't be a string because how can it be held then? But see, the trick is that we have a little hole in the glass. That's the trick. So we hang this thing by a little thread that you can't see, and then you can't see the entire glass. You don't see, we don't film the whole thing. And we carefully lower the glass so that it doesn't, affect the little string there, okay? So that you can't see how it's held, okay? And so people really believe that, this happens on Earth, okay? It's all these little tricks that we like to do to mislead. The point is to mislead. That's the point, to keep you on your toes, to keep you guessing. How did he do? Oh, that's the idea. And let's see, I've got another one here. Oh, here it is. Okay, and here you can see, this is also, this is fake. We tell them, look, it's magnetism. No, this is held by a little fiber that you can't see. It's held from the ceiling, okay? And see how careful the guy is to turn it around and to touch it, because otherwise it's going to wobble all over the place. You're going to find out how the trick is done. So the guy just turns it very slowly, to make sure that the string doesn't wobble back and forth, okay? So yeah, we do all these tricks, and yeah, fortunately, most people were fooled, and this is how this is our job. We're in the disinformation department. That's what we do. So what can I say? Yeah, now that some people have discovered some of the tricks, we have no other choice but to blow our cover. And Trump is going to be telling the world, in a few days, couple days, that all this stuff about going to space, taking pictures from outer space, are you kidding me? That's all a hoax. It's all a hoax. You just can't accept it. It's just, and just for your information, I don't know how many of you are as old as I am, but and I wasn't too old at the time, but I even heard it, when I was small. I was only 5 years old. It's 1957, in the Russians sent a dog out into space, okay? And let me show you that, because that's important, because this is where the thing began, more or less. This is where this space exploration deal, this is where they started fooling people, with it. And here they prepared a dog. Her name was Laika, okay? And people believe that they really sent the dog out into space. Can you believe that? They sent this dog supposedly out into space, and the poor dog, astronaut, trained as an astronaut, no spacesuit, okay? And the dog was just there, just traveling through space. And, we knew that the thing wasn't going to come down. So, we sent that dog, supposedly, right, to fool people that this dog really died in space. And a lot of people believed it. That's the interesting thing, that people really believe that this happened, that a dog traveled through space. And, it probably manned the controls, was trained as a pilot. Yeah, probably, Laika was a very trained dog. No, let me tell you what really happened to Laika. Laika was taken to a dog gulag, and she was eventually slaughtered. She had to be slaughtered because, what if the press wanted to interview her? Come on. And so, yeah, we chopped her up into pieces, and we threw her out, to as dog meat. So yeah, Laika never went out into space. That was a hoax, total hoax. So you can't really believe all this stuff, but you guys figured it out. But the majority of the world swallowed it. That's the fun part. We were pretty good. You got to hand it to us. We really convinced the world. 99% of the world believes in all this nonsense. And all those people, who held steadfast to their ideas, they didn't swallow all this BS. We got to hand it to you. The flat earthers really vibrate. Anyways, today I was going to talk about different things, but it just got so lengthy what I was going to say today that I said, no, I'm going to divide today's presentation two pieces, two parts. And today I want to just finish up with the flat earthers. Then on Wednesday, I'm going to summarize what I dealt with the flat earthers today. And then I'm going to move on to the electric universers, the John Chappellers, aetherists, and so on. I'm going to go beat up on them a little bit as well. But today I think I got enough on my hands with the flat earthers, okay? And so where do I start? Well, we start with where I ended up the other day. What is science? And it's better to start with what science ain't, okay? So here it is. If you do any of these activities, you are not a scientist, okay? If you observe, you study, you analyze, you predict, you make predictions. That's astrology. You collect data, you do math in any way, shape, or form. You do equations, you describe, you know, a lion runs 30 miles per hour. Okay, is that science? And yeah, if you observe and study, does that mean you understood? You can observe ants all day long, and you see them going into the to the hole, and you can even see a cross section of it. Maybe you observe that. Does that mean you understood what's going on in there? Observing, studying are not part of science. Anybody can study. You can study for the test. Does that mean you're going to pass the test? Yeah, so observing, gawking, as I call it, gawking is not part of science. And especially because there are no observers in science. Science is objective, and observers introduces subjectivity. Do we present evidence in any way, shape, or form? No, we don't. There is no evidence. Why? Because evidence is used to what? To persuade, convince, convert, and recruit on the upper right hand there. And in science, we don't do that. That's in religion. It's the prosecutor in a law room, in a courtroom, who goes in there and tries to convince, persuade, convince, persuade the jury, or trying to recruit the jury to his side of the case. He does some arm twisting, okay? And that's not part of science. In science, we don't care what you believe. That's why, know and believe. Knowledge has nothing to do with science, even though the word science derives from Syria, from the Latin that means knowledge. That's because the ancestors screwed up and they thought that science was about knowledge. It's not. It's not about knowledge, it's not about belief. And part of it, it's not about knowledge, because knowledge is defined as justified true belief, which is Plato's definition of knowledge. And that's pretty much the same one that we're using still to this day. Okay. So, in science, we don't know. We don't know and we don't believe. Okay. In science, we assume. We make an assumption and then we explain the theory. Okay. We don't censor theories. That's politics. Okay. Again, that's not part of science. I mean, it happens, right? It happens, but it's not a part of science. And of course, part of that censorship is this flat earth issue where people say, oh, there's a conspiracy. Yeah, conspiracies. Let's assume that, let's concede. Okay, there are conspiracies against the poor flat earthers. Okay, let's concede. That's not part of science. That subject matter is not a part of science. In science, you have to explain a mechanism. So even if Trump and the entire CIA and the FBI and the NSA, all these are conspiring, we don't care. It has no bearing on science. Science, you got to tell me how a magnet works. In science, you have to tell me how gravity works. That's science. And I'm not sure how, a conspiracy uh, affects that, your explanation to me. Okay? So that's the issue. Okay, we don't rely on authority. Authority is outside of the bounds of science. We don't vote for theories. Science is not democratic. It's not majority vote and say, oh, your theory is correct because 50 plus 1, 50% plus 1 voted for your theory. That's not the way. Mother Nature laughs at that. Mother Nature doesn't care if everybody votes for the flat Earth, theory. Okay, she doesn't care about that. So voting, democracy is not a part of science. Do we testify? Do we bring a witness and gives us his personal opinion? No, we don't care about witnesses because again, that's subjective. Okay, so we don't care about any of that. And so what's the issue with this? Well, the issue is that we end up with this irrational scientific method that we have today and that we've been using for the last 400 years. And this is in a synthesis, what most people believe out there. This is how you were educated in high school, okay? And all these people, these groups, they believe that you have to use your vision, your hearing, your smell, taste, and touch, all your senses, right? You have to observe, collect data, hypothesize, predict, run experiment, verify. We don't do any of that in science. None of this has anything to do with science. We don't run experiments, okay? It's, you can do whatever you want before the conference, but when you're at the conference, you have to explain. That's what we do in science. We don't do any of this. What we do is explain, okay? That's what we do. We explain. And yeah, some people have trouble understanding all this because they say, hold it, we've been doing experiments, we've been observing, we got all this technology that we developed. We wouldn't have it if we didn't do all the things on the left. Well, the problem is that technology has nothing to do with science either. I mean, technology means that, you go out to visit the Vikings or maybe the pygmies out in the jungle, the natives, and you take a little magnet and you sprinkle some iron filings on the ground or on a table or whatever. And then you do your magic. You say, okay, guys, watch closely. And you put your magnet there and it picks up all these iron filings through space, through emptiness. And all the natives go, oh, magic. Well, that's technology. You can use it for something. You can use it to lift cars. That's what they use the magnets for, among other purposes. But the issue is that's not science. That's technology. Science is tell me how Mother Nature did that magic trick. That's science. Science is the explanation of that phenomenon. And yeah, well, one of the problems we have is that all these people, they have no idea of how to explain these things, and so they describe and they think they have explained it. And so this is how we do it at the Bill Gates School of Physics. What we do is we apply, violent means. And John Cleese of Faulty Towers, he explains essentially how that's done. We subscribe to his philosophy. Please try to understand before one of us dies, okay? You know nothing. And then, yeah, you go get a branch and you start beating the guy up, He beats up his car and he gives him a damn good thrashing. And we like to give anyone who subscribes to the old scientific method, we give them a good thrashing. Okay, that's what we do at the Bill Gates School of Physics. Okay, so just keep that in mind. If you do not understand, well, please try to understand before one of us dies. Okay, that's our philosophy. Okay, so what is our scientific method? Well, it looks something like this. You can compare them side by side. You can see these two scientific methods. The one from the 21st century is very different to the one that you've been educated with in high school and college. Mathematical physics, they use all these senses, and they don't use the only sense that they're supposed to be using, which is your brain, the mind. This is your thinking. That's what vibrates in science. And yeah, we have three parts to the scientific method because you're going to explain something. You're not going to run any tests. You're not going to prove anything. You're not going to verify anything afterwards. You don't do any of that. Not in science. What you can verify whatever you want at your home for yourself. That's your problem. That's for your belief. Okay, that's so that you are convinced of something. But in science, all we do is explain so that you understand the mechanism. In order to do so, you have to present the objects that you're going to be using. You're going to have to define certain terms very specifically. And then you have to present your initial scene. That's going to be your assumption. That's going to be your hypothesis, your initial scene. What is your starting point? You know, you can't start in the middle of the race. You got to start your movie always on a first frame. And that's what a theory is. An explanation is a movie of the causes and mechanisms, okay? So that's essentially, you can see the differences between these two scientific methods, okay? You might ask, well, if it's rational explanation, what is rational to you is not rational to me. That's an opinion. No, we have criteria for what is rational. If we're going to define rational explanations, you better have a criterion or a set of criteria for what you mean by rational. What is rational, okay? And so we do have that. We had to develop that because, you know, that's also come up many times. And here it is, okay? That's a synthesis of it. It's not limited to this. But if you convert a concept into a physical object and then pretend to move it around, that's the big one. You can't move love around. You can move a heart around. And you can say that, well, look, with a heart, I'm going to represent love. Okay, so far so good. You can say, okay, you reified a concept, but yeah, what are you going to do with that? Well, let me move love around, and you begin moving the heart. No way. You better move love. You know, if you can't move love, it's because it's a concept. That's why you can't move love. And likewise, you can't transfer energy, and you can't vibrate a field, and you can't move a mass because all these are concepts. Okay, you can't wave the wave. And obviously, you can't even, shake the ether, okay? Because all those are concepts. And so, whenever you use any of those words, what you're doing is actually moving a concept, attempting to explain a physical mechanism by moving a concept. And until you understand that, well, yeah, please try to understand it before one of us dies, okay? And yeah, using key undefined words, energy and mass to this day have never been defined. Neither has the word field, neither has the word charge. So anyone using these words, they're not only introducing concepts as physical objects, but they are introducing concepts that have never been defined. Mathematical physics is full of, concepts that are undefined. And they've been using these for 400 years. They convince you on the basis of these concepts, and then at the end of the story, the punchline is, oh, by the way, we don't know what energy is, and we don't know what mass is, and we have 7 different definitions for mass. And field, well, it's whatever Faraday defined in the 1840s, and so on. So you never have a definition of what these concepts mean, aside from the fact that they convert them into objects. Okay, then the theory must follow from the assumptions. And I always give the example, if the prosecutor presents a knife at the beginning of his presentation, he cannot later on tell the jury, and the victim was poisoned. Huh? What do you mean? I thought the weapon was the knife, and so the theory has to follow from the assumptions, okay? And yeah, and the last one was there that you cannot claim to have explained when all you did was describe. And just to put it in the right context, mathematics, the discipline known as mathematics, which is really just a language. That's all it is. It's a language. And mathematics can only describe. That's all it can do. And it's a quantitative description. If you look at it seriously, like I did, you'll find that mathematics is a language that only contains adverbs which are quantitative adverbs. It's a language solely of adverbs. It doesn't even allow adjectives. You don't need the word black or the word big in mathematics. You know, mathematics wants a number, wants a value for that bigness. And if you're going to talk about a color, yeah, they want to talk about frequency. You know, they what's the frequency or what's the wavelength? So you can't say the black cat. You know, they have no use for a black cat, for a green tree or whatever. They have no use for adjectives. They have use for adverbs. How something moved, and it's got to be quantitative. You know, you can't just give me a qualitative explanation. No, you need to have put a number and a unit behind it. Then the guy can understand what you're saying because he's, you know, that closed. You know, he's got this tunnel vision, and so he can only see quantitative motion descriptions, and that's all mathematics is. So mathematics as it relates to physics, okay? There's pure mathematics and there's mathematical physics. Mathematical physics purports to explain how the real world functions mathematically. And so they claim that mathematics describes, not explains, describes the world. And since they have never been able to explain any invisible phenomena qualitatively, right, in the last 400 years, mathematical physics has evolved into a synonym of science. And so people say, well, what is science? Well, science is mathematical physics. What do you mean mathematical physics? Yeah, see, we have a description of the universe. We have a description of how the earth goes around the sun. We have a description of an eclipse. We have a description of gravity. We have a description. It's all descriptions. And what are these descriptions? You go in there when you take courses at the university, you'll find that they're mathematical descriptions. They're quantitative descriptions. That's all you get. So if you're not interested in that, please don't go to college to take courses in mathematical physics because you'll be swamped with just that nonsense, just mathematical description. That's all you'll get. You will never get an explanation, a qualitative explanation that you can sink your teeth into. You know, that's the point. Okay. And so what do we do? Well, in real science, right, in genuine science, in 21st century science, the new scientific method, okay, we have to define our terms. And the first one is that we have to define science itself, rational explanations, okay? Physics is done with objects, and it purports to give you an idea of how causes and mechanisms are carried out, especially by Mother Nature, especially her secret world, her invisible world. Philosophy deals with concepts, reasons, and purpose. Okay, that's the realm of philosophy. So science only has two branches. Okay, and everything that deals with objects, causes, and mechanisms falls on the red side. And in order to know what physics is about, well, we had to establish the foundations of physics. Okay, and the first thing, we start with a principle. You can't do physics without an object. If you wipe out the entire universe of all its matter, well, then there's nothing going on. Well, what's happening? And so, yeah, what we have to do is we define these terms, and a specific term we have to define is that word object or the word something. We need to know what something is and what nothing is, and they have to be antonyms. One is that which has shape, and the other one is that which doesn't have shape. Now we know what nothing is, and a synonym of that is space. Space is absolutely nothing. It's the same thing as vacuum. There is nothing there. Okay, so we have nothing and something. That's what our universe is made of. The other important word there is the word exist. Okay, physical presence. Keep that one in mind because physics is the science that studies existence. Physics only studies that which exists. Okay, now what happens? People have introduced the ether into space. They say space is filled with what? Well, they had to fill it with something. And since the days of the Greeks, all the way to today, everybody's been thinking in terms of particles. There's this, buzzing bees out there, this hive, this sandbox, but it's a vibrating sandbox. It's all moving in the background. What is it? Bunch of particles. That's the definition of the ether. That's a scientific definition of the ether. Bunch of particles. That's what the ether is. It's a sandbox, but it's a sandbox that's quite unlike the one you see in the kids' playground. It's a sandbox where all the grains move. Okay, that's what it is. Okay, and so what happens? is the definition bunch of particles. Does that qualify as a physical standalone object? Does it qualify as something? And the answer is no. And the first clue is that if you can define a word, it's not an object. Okay, let me repeat that. Please try to understand before one of us dies, okay? If you can define a word, it's not an object. Okay? You can't define the word table. Okay? So, oh, Bill, but I looked it up in the dictionary. No, what you'll find is a description after you pointed to the thing called table. In science, we point and say table. Now the ET understands our language. He knows what the word table means. The sound, he identifies the sound with what you pointed to, with the image. So now we know what an object is. And you got to think of this object as the only object in the universe. And you got to think, and if it's the only object in the universe, it's not made of anything. Okay? In other words, when you say table, you are referring to the whole thing and not to what it's made of. And when the ether guys say, ether's a bunch of particles, the ether is all this vibrating part, then they're not talking about a physical object. What they're talking about is a definition of a background. That's what they're saying. And here, let me give you another idea, because it's known as mereology, by the way. And here you get an idea of why the word ether does not qualify as an object, okay? You point to an elephant, and you don't say, well, what is the elephant made of? See, the elephant is not all the atoms that make up the elephant. Because then I would just say, well, an elephant is a billion particles. And what have you learned by saying, oh, a billion particles? What are you referring to? Are you referring to a house, an elephant, a building? So we don't know what a billion particles refers to. Here you have another one, a marble. Is a marble all the little atoms that make it up? Is a chair all the atoms that make it up? No. Chair is the solid one-piece thing that you see, and you got to treat it as the only object in the universe. You point to it and you say table, you say chair, you say marble, you say elephant. And, mereology is a religion invented by philosophers who had nothing to do. And among the things that they invented is that you have this temporal parts, that you don't see a table in one go. You see it in reality, like in your mind, piece by piece. So you kind of build it like from left to right. And that's not a table. That's a movie of something moving, or a table being built, or any way you want to look at it. That's not a table. Table is what you point to, okay? And that's the issue with the ether. See, when you go out there in the ether, you don't have to say bunch of particles. That's not an object. An object is the outline of the object, the whole thing. And by the way, shape and form are synonyms in physics. One guy said, well, shape is not form and form is not shape. Well, you're introducing words of ordinary speech, okay? You're introducing words of ordinary speech, the definitions of ordinary speech, where we apply form to three-dimensional objects and shape to planes, to squares and circles. That's not the case in physics. In physics, anything that has shape, anything that has form, anything that has an outline is a physical object for the purposes of physics, because the word physical and the word object are perfect synonyms. What you're confusing is existence versus object. And, both David Hume and Immanuel Kant had problems there, because they couldn't tell the difference between an object and its existence. And yeah, you fall into all these philosophical traps, ontological traps, okay? And why is this important? Well, because imagine you have a field, okay, around a magnet. And the question is a field a physical object? Is it a standalone object? And here you see that it's not. See, a field is something in motion. So you cannot say, oh, the field did this and the field did that, okay? That's not the way it works in science. First, you have to define what physical object is underlying the field. You have to tell me what a field is made of before you can use that as a physical object. And right now, you can see that the field is something in motion. In the case of the bottom left there, you can see that the field, so-called field, is pulling one iron filing at a time. And on the two upper ones, you can see that something is moving. Okay, and really, a field is something in motion, and both Faraday and James Maxwell stated that. It's matter in motion. They didn't know what matter it was, what kind of matter, some sophisticated matter that they could not imagine. But they say, look, whatever a field is, it's matter in motion. So let's forget about the word field. Let's find out what this matter is. And I'm saying those lines of force that the deranged mathematicians tell you are abstract, they're real. The lines of force are the threads of the rope that go around a magnet. Now we can explain not only the so-called field, why iron filings align along the field. That's the first observation. But we can also show, with this, how, a magnet attracts another. And here you see it. Let's see if I can put it up here. Got so many of these. Here it is. Okay. You can see the mechanism of how a magnet attracts one and another with the threads. If the threads were abstract, as these people say, then what physical object is pulling on another magnet? And you're going to say, well, there is no physical object. I can't see anything there. Well, if you can't see anything, does that mean it doesn't exist? If you can't see the air, you haven't breathed it? No, there's got to be a physical object that has effect over metals. Okay, for example, right? And if it has an effect over metals and not over your body, for example, you can't touch that field, but the metal apparently can, because the field has the ability to move an iron filing. Matter which is seeable and touchable is being moved around by something which is not seeable and not touchable by our hands. So we have to try to simulate that. And what I'm saying here, you have two mechanisms, and the important thing is to try to understand the mechanisms here, because people immediately say, oh, what is the rope made of? And how come ropes don't cross each other? And do they extend that far? And how much do they weigh? And they have all these millions of questions, and all I can do is bang them over the head and say, please try to understand before one of us dies. The answer is that you're supposed to first tell me if you understood the mechanism that I'm illustrating here. Do you understand the mechanism? And the mechanism on the left shows that as the threads move around the magnet, okay, when one comes down, it pulls up on the one that comes up. And on the right-hand side, you have the repulsion mechanism. That's when you turn in the south-north direction, you turn the magnet around, and now south faces south. Now you have the threads hitting against each other and pushing each other away. Do you believe that this is the case? I don't care, because the point is not for you to believe. The question is, do you understand the mechanism I just illustrated there? See, people want to have a million questions. They haven't understood the mechanism. Please understand the mechanism before one of us dies, okay? So if you understand the mechanism, we're finished with science. Now we part company. You go to your home. You do whatever you have to do. And you either believe or you don't believe. That's your personal problem. We don't care, okay? But the first issue is, do you understand? People don't understand. They start asking questions. And you say, hold it. Did you understand the mechanism I just explained for the last hour? And the guy said, I don't know, but what are these ropes made of? No, it doesn't work that way. First, tell me if the mechanism is correct. And then the next question, I get to ask it, not you. And here's the question. Because some people say, well, Bill, I can also do it with angels. I can do it with spirits. Okay, I'll go with that. I won't fight it. I won't even ask what the mechanism. Maybe the angels play patty cake. They push each other away, and maybe they hold hands and pull each other forward. I don't know. We can do it with angels. I'll concede, and we can do it with threads. And some people confuse the rope with a thread. They don't know the difference. Okay, it takes a long time to explain to them that the thread is not a rope. A rope is not a thread. A rope. Some idiots ask, well, what is the rope made of? And that's why we start fooling and messing with them, because we know they're idiots by nature. A rope is made of two twined threads, wires, strings, whatever you want to call it, cables, coaxials. A rope is made of two twined something. So don't ask the stupid question, what is the rope made of? Okay? because that means you haven't even paid attention to the fact that a thread is not a rope and a rope is not a thread. You haven't even gotten that basic thing in your mind. So before you ask questions, do you understand the mechanism? Do you understand that it's threads moving around, not ropes? The two little guys with the ropes, they're there for simulation. But then the simulation done in the magnets is done with threads, not with ropes. Okay, the ropes don't swing. Ropes are always straight, always tight. Okay, taut. Okay, so we can explain it, and the question is, how about the flat earthers? Can how do they do all these things? And the first problem we have with the flat earthers is definitions. Uh, they can't tell you what the word flat means. And this is I'm not going to go through all of this. I'm just saying that this is the official version from what is it, from mathematical physics, that if you walk around a room, and you do 490 degrees turns, dot, 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 and so on, and you arrive back at your place, according to them, that's the definition of flat. And if you do it 3 times or 5 times, an odd number of times, then it's not flat. That's what they call flat. Okay? That's in their minds what they call flat. Okay? They explain it with an experiment. They say you got to walk around the room to find out if it's flat. Okay? Now the more popular version is the one you find in the dictionaries, and over there essentially they say, look, it's whatever is smooth. Okay, a smooth surface. And one guy raised the issue there. You said, you're telling me that the table is not flat? Well, it's about as flat as your head. That's what it is. There's no such thing as a flat table or a flat surface in physics. Why? Because people are thinking in terms of this definition. This definition says that anything that's smooth, level, etc. is flat. No, not in physics. Okay, that's in the religion of ordinary speech. That's in the religion of mathematical physics. That's not the definition of flat in physics. In physics, flat means 0 thickness. That's different than saying a surface is smooth. And of course, with either definition, the flat earthers have a big problem because, Mount Everest sticks out of the ground, unfortunately. So you can't even have a flat surface or 0 thickness. So the question is, what is the definition of flat of the flat earthers? Okay, and see, they try to skip over they don't do definitions, so they say flat earth, but they don't know what flat means. I mean, is a pancake flat? Well, we say in ordinary speech, well, the pancake is flat. I have a flat tire. Is the tire flat? Well, no, it's just flat at the bottom where the car sinks into it. So is that flat? Is that what we mean by flat in science? Is that the scientific, perfectly intelligible definition of flat? No, of course not. Flat, 0 thickness, and there's no such thing as 0 thickness in physics. So the first action item for the flat earthers is go out there and figure out a definition for the word flat. Number 1 task that they've got to do. Okay, so how do we define it in science 0 thickness? I'll just skip over that. But what today's lecture is a little bit about is how they do gravity. Okay, that's what is of interest to me, because flat Earth is not only they dedicate 99% of their talk to conspiracies. It's all conspiracies, all politics, all chatter at the water cooler. And they do a lot of videos, and all they talk about is how the government is trying to screw them and mislead them and all this stuff. It's all about conspiracy. And you say, okay, the conspiracy, that's great. That's religion. That's politics. What mechanisms do you propose? And so, when you go out there, you see this. You see how they do gravity. Okay, and so this is the Flat Earth, by the way, Society. This is the main group, and they say, well, we're pushing the Earth up with dark energy or dark matter. It really doesn't matter. Dark whatever. It's always dark. It can't be something white. It's quite racist in that sense. So it's dark energy, dark matter, and it's pushing the Earth underneath. Okay, so Newton's apple did not fall on his head. The earth pushed Newton towards the apple. That's the explanation from these guys. Okay, already we have a serious problem with just the intuition of this. How this can be working. It's really mind blowing and breathtaking, right? And as part of that, they say that somehow. Oh, sorry, wrong one. Let me get this one here. They say that the light rays in the universe are bent. This comes from their site, okay? And they say, look, see if I can get it lower here. They say that the beams of light are bent. And they say, yeah, and the reason is very clear, and that's that second paragraph there, is that it would be quite unreasonable to assert that a particle or wave in motion would travel forever through the universe in a perfectly straight line, unperturbed by any of the variety of forces or phenomena which fills existence. Well, the first problem is they're still using particles and waves, just like the people they criticize, which is the establishment. That's the first screw up. And then the other one is that, they're talking about forces, mysterious forces, bending them down. Well, if you got a particle, what's in contact with a particle? Why is a force, whatever a force is, how is the force physically pulling on light downwards or upwards or distorting its path? That's what they have to explain. And you can't just say gravity does it, because you got to explain gravity, especially with these people don't even believe in gravity, because they say it's the earth coming up against something, because something is pushing it underneath, which they never defined, etc., right? So it just goes on and on. You never have an explanation, okay? And but just for those of you who are not aware, in the Spanish site, they really criticized me the other day quite a bit. And they're not, you don't have to offend them. You don't call them the flat earthers, okay? Just keep in mind that there's a different group. These are dissidents of the dissidents. And what it is you have not the flat earth, they are the plain earth society. They do plain earth. And their form of doing gravity is a little different. That's where they differ, okay? There's a difference in how they handle gravity, especially there, okay? They still believe in the Antarctica around the flat earth. They have that model. But I love their model because, it's a little better because it's got a dome over it. Here I have, this is my Eiffel Tower I got from Paris. And think of, half a dome there, right? And they say that all the snow, going around that covers the earth, the flat earth. So we're protected from space by this dome that's out there, okay? And so keep that in mind. And the flat earthers are not the plain earthers, okay? So you can't mix them up. And so this is their site. I translated, it's in Spanish. I translated it into English, okay? And you can see it says, gravity is a hoax. I like how they start their presentation. They start it with conspiracy. That's how they started. Okay. So let's assume that's the case. So how do they explain gravity? I mean, what is the explanation? And you can search throughout the whole internet, and all you'll find is this little thing here. That's all you find. This little paragraph, this little one-liners here. And essentially they're saying, look, here we get to the heart of the matter. Logically ask ourselves, why does Earth attract objects? Yeah, good question. Why does Earth attract objects? What is your explanation, dear plain Earthers? And they say, okay, here we have it. The reality is that no one can explain why the Earth attracts objects. The Earth supposedly attracts objects, but they, the other people, they cannot explain, why it attracts them. But see, the flat earthers, they know exactly how the earth attracts objects. And here you have it. The concept of gravity could be replaced by density and buoyancy. That is, everything that weighs more than the air falls, and everything that weighs less floats. Perhaps Newton's apple fell simply because it weighed more than the air around it. Oh man. I mean, Jesus Christ, this is so great. I loved it. These guys are going to explain gravity with density and buoyancy. Where did they get this? Well, they got it from this fellow. He's famous for running nude around the town, yelling "Eureka!" His name was Archimedes. And Archie, he was in the bathtub and he had a task from the king. The king wanted to know how much gold was in his crown because he felt that the blacksmith screwed him and put some cheaper metal in there. And Archie figured it out. He just dipped it into his bathtub, into the water, and displaced some fluid. And he figured out that the buoyant force equaled the weight of the displaced fluid. And so he ran through the streets naked, telling everybody that he had figured out something. Anyways, you can see there the flat Earth of the plane. I'm sorry, the plane. Sorry, plain Earth, and they have a dome over the flat pancake Earth. I'll call it just to keep in line with all of them, so that I don't offend anyone. Yeah, it's the pancake Earth. Okay. And so one of the issues that comes up that you might be pondering, since these people say, Bill, what's happening here is that, you have lower density medium, like air, and, things fall through the air into the water. Water is more dense, and so it goes slower and so on. So this is how they're going to explain it. Well, what if we turn these media, around? What if we put water on top and air on the bottom? Would the object, the ball, go from air to water? I mean, you go from lower density to higher density. You shouldn't fall to Earth because you're in air. You're in this medium of air, right? And it's very close to this denser medium, which is water, right? And so you would think that the ball, if they're correct, would move upwards and not downwards. So here's an experiment that I want to offer you. Okay, you take a beaker, transparent beaker, and you fill it up with water, completely with water. Okay, and then just put a thick coating of oil on top so that it looks something like this. Okay, now you have the denser medium on the top. Okay, and the rarer medium on the bottom. And now put a ball there at or a grain of sand if you want, in the middle of the water at the bottom somewhere. Will it go up? Will that grain move to the higher density medium? Is that what they predict, or is this what they suggest? Is that how it works? Well, I think their experiment's going to fail at least here, right? So that's my guess. Okay, but you can try the experiment at home. Don't believe me. I'm a disinformer anyways, that's my job. Okay, so how do we do it? How do we do gravity in science? Okay, let's because all the morons, all the idiots of mathematical physics, they do it with warp space, okay? And they do space, time, whatever nonsense there. And quantum mechanics, it does it with, a negative momentum transfer. It transfers a particle, a force, that has a negative sign. And so you throw the ball or whatever force at the donkey, and that's what attracts the donkey towards you. You throw negative momentum to it. And then the bean brains of general relativity, they say, no, it's a warpage of space-time. And so, yeah, we got to get rid of all these people because none of them have any idea how gravity is done. And so let's see how gravity is done. Okay, here's the proposal from science, from the rope model. Okay, here's the synthesis. And I explained it in other videos, so you can look it up. I've got several videos on this. But essentially, every atom in the universe is connected. Okay, all atoms are physically interconnected by an elongated rope. Okay, that's what it is. That's what I call it. It's a twined pair of threads. DNA probably imitated the rope. In fact, I just wrote an article in Quora saying that all these, collagen and every strand that you see in the biological world, it's all elongated. None of them are particles. They're all elongated structures. And I think they all imitated light, which is what underlies all of them. But anyways, how do you produce the acceleration of gravity? Well, if all objects are physically connected, if all atoms are physically connected, now we can see that as an object drifts, not pulls, but drifts towards another, it drifts. Why? Because as the objects approach each other, the threads that are pulling along a same axis now pull or act along a different axis. As two objects get closer to each other, all the ropes fan out and one object approaches the other. Okay, there is a reason for why a person, for example, a human being that falls from an airplane, or just in the case of the question, why don't we fly out of the earth, right? If the earth is round, right? How is it that we fly out of the earth? And here's the explanation. You see it in a single picture. Okay, that's why. Because every atom in his body is connected to every atom on Earth. That's why he doesn't fly out of the Earth. The Earth can rotate at whatever speed. We're not going to, well, not at whatever speed. At faster speeds, we probably would fly out, or at least go out into space. But as long as Earth maintains its rate, there's no reason for anyone to fly out, because there's gazillions of ropes connecting every one of the atoms in your body to every atom on Earth. Now, where did I get this? Am I crazy? I mean, what are these ropes? How do I know that these ropes exist? In science, we don't know. Anyone using the word "no," we call them an idiot. That's what happens. So if you use the word "no" in any way, shape, or form, you are an idiot, because knowledge has nothing to do with science. In science, we make an assumption. What is the assumption? Where do we get this assumption? Well, here we'll let Professor Muller tell us. You know, he's a professor at Berkeley, and he says, for example, you know, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Now, how else are you going to simulate this unless you have this situation? Please tell me. What was he describing a minute ago? Isn't he describing that every atom on Earth is pulling on every atom of you? You are pulling on it, and on each one of those. And not only that, but why does gravity go right through things? Because many of the ropes superimpose. That's why. The explanation's right there in that picture. Every atom on Earth is connected to every atom of you. Just take any axis along there. There's got to be ropes from one atom right behind the other atom, right behind the other atom, right behind the other one. That's why. That's why one atom shields the other atom from you, and the rope goes, you know, along the same axis. That's why. Okay, now we can explain gravity, not only why every atom on you pulls on you, but why gravity goes right through things. The only explanation is an elongated physical mediator that Mother Nature uses that we can't touch and we can't see. And to try to simulate this as you know, the flat planers, the plate earthers, the pancake guys, you know, they say, well, Bill, let's go to the lab, see if we can reproduce your experiment, reproduce what you're saying experimentally. And what they're trying to do is, with something which is visible and touchable, they're trying to simulate something, gravity, which is invisible and untouchable. That's what they're trying to do. And of course, they're never going to be able to simulate it in the lab. And again, that shows why experiment has nothing to do with science. Science is staying back and trying to explain how Mother Nature does her magic. Whether you believe that's the way she does it or not, that's your personal business. Here we're trying to visualize how she might be doing this. And if we put a little rope there between every atom in the universe, now we can explain attraction, because as two objects approach each other, the ropes fan out, and then you accelerate faster and faster and faster. You're actually drifting faster and faster and faster to the center of the Earth. That's what's happening. At different levels, you have, you know, different levels of rope. Okay, that's what it is. And I'm not going to go through another feature of gravity, which is if you fall to the center of the Earth, if you were to make a hole all the way to the center of the earth, like French guy told us, a voyage to the center of the earth, um, you would fall, but now the ropes are pulling you also from the matter that's behind you. So you would fall and you would fall slower until you reach the center of the earth. Maybe you overshoot it because you have some velocity, and you would go back and forth until you end up in the center of the earth. Okay. So, but that's a long story to that's outside the topic. I'm just going to show you as a closing argument here. I'm going to show you one of the things that you can explain with a rope model, and that's this. Okay, that's that every atom in the universe is connected to all others. So a galaxy is not only bound together. Every atom in the galaxy is bound to all others, but that means that all the stars are bound to each other. So if we just imagine a spider webs of stars there, and we place it on top of our rotating galaxy, we can get an idea of why stars on the outer edge not only travel at the same speed or faster than ones on the inside, but you can get an idea of why they don't fly out of the system. Why doesn't the rotation of the galaxy throw these outer stars out? There's not enough mass there to throw them out. And what the mathematicians have done is fill the black spaces that you see there, they filled it with this dark matter. And outside of that, I guess you got dark energy, and I guess that dark energy is what pushes the earth, the flat earth, upwards. So that's in a nutshell what all these people have come up with. No, we have to make a new assumption, and the assumption that we make is that all atoms in the universe are interconnected, physically interconnected. Okay, rope is very thin. You can't see the rope because you're using light, which is mediated by a rope, and you're trying to see the same rope. You're trying to see the rope with another rope, and there's nothing there. We can only see atoms, when they're bunched up. We see an object. We can't even see an individual atom, let alone, the rope, which is much, much thinner than an atom. You're talking about all these ropes converging upon an atom, comprising the atom, and leaving on the other end as a rope, and twining on all the way to another atom. So you're trying to see something that first is unseeable and untouchable by us 3D object, yeah, that's what we are, 3D humans. And you're trying to simulate that which is invisible and untouchable with something that is visible and touchable. It can't be done. And you're asking for something irrational. So please try to understand before one of us dies. And otherwise, I'll grab my baseball bat and learn you something. Okay, I'm going to continue with this line of thinking on Wednesday. I'm not done with this subject yet. And I'm going to touch upon especially the, I call them retards, and that's a technical term. Scientific term of the electric universe and the people who propose ether in any way, shape, or form. So I'm going to be addressing them and do a little summary on what I did today. So we'll see you on Wednesday, guys. We'll see you then. Bye-bye.